In this video, I'm going to evaluate the double integral 0 to infinity x to infinity e to the power minus y by y divided x by changing the order of integration. That means you have to get new limits of integration. For according to this given one, the given question, the limits of integration for x will be from 0 to infinity, and for y it is from x to infinity. But now to evaluate this one by changing the order of integration, I need to get new limits of integration. That is, for y, it will be in terms of constant, and for x, it will be in terms of y. So first step, what we need to do, we need to draw the graph of these limits of integration. For x is equal to 0 to infinity, and for y is equal to x to infinity. And from the graph, we can find out the new limits of integration. So first of all, let us write this one. The limits of integration for x is from x is equal to 0 to x is equal to infinity. And for y, that is according to the question, and for y, it is from y is equal to x to y is equal to infinity. Now, let us draw the graph of x is equal to 0, x is equal to infinity, y is equal to x, then y is equal to infinity. So here we are going to draw that one. Then now what is x is equal to 0? X is equal to 0 represents a straight line which is along the y-axis, or y is equal to this one. So this one represents x is equal to 0, and this is actually the y-axis. This is 0, the origin. Then x is equal to infinity. X is equal to infinity, that means the value of x is infinity. So that means it will be this side. Okay, so here for different values of y, you will get value of x as infinity. That means infinite. Now next, draw the graph of y is equal to x. Y is equal to x is nothing but it is a straight line which passes through the origin. So this is y is equal to x. Now y is equal to infinity, that means the value of y along the y-axis is infinite. So this will, the required region of integration is this one. It is bounded by x is equal to 0, then x is equal to infinity, that means this will keep on increasing. And then here also, y is equal to x, that means it is bounded by this line y is equal to x, and y is equal to infinity, which is along the y-axis. So this will be the shaded, the required region of integration. Now from this area, you need to find out the limits of integration. For x, it will be in terms of y, and for y, it will be from in terms of constant. Now here, this one is the y-axis, or sorry, the x-axis. Then this will be y is equal to 0. So let us find out the new limits of integration for this region, which is bounded by x is equal to 0, x is equal to infinity, y is equal to x, y is equal to infinity. So now you see that here it is bounded by this line y is equal to 0. That means y varies from 0 to infinity. And x here, it will be from left to right. So it will be x is equal to 0 to x is equal to y. So that will be the new limits of integration. So now here you can write this one, solve this one now. From the graph, the new limits of integration are for x, it is from x is equal to 0 to to x is equal to y, because we have for when we find the limits of integration for x, always remember that it should be from left to right. So on the left side, it is bounded by x is equal to 0, and on the right side, it is bounded by the line x is equal to y. And for y, it will be along the vertical line, that is below it is bounded by y is equal to 0 and above by infinity. And for x or for y, it is from y is equal to 0 to y is equal to infinity. Therefore, that double integral e to the power minus y by y dy is 0 to infinity, then x to infinity. By changing the order of integration, it becomes now for y, it will be from 0 to infinity. So we'll have to write first the limits of integration for y. Then the limit of integration for x, it is from 0 to x. So this will be e to the power minus y by y dy. Okay, we have to integrate with respect to x first, so we'll dx then into dy. And this gives you integral 0 to infinity. Then now see that this e to the power minus y by y is will act as a constant when you integrate with respect to x. So what is the integral of dx? It will be x. So we'll get it as e to the power minus y by y will remain there, dy, then into x from 0 to x. And this is called integral, it is from the limit of integration for x, it is from 0 to y, so this is y. So it will be y, so we'll get e to the power minus y by y. Then when you substitute the limit of integration for x, it will be from 0 to y, you'll get y only dy. Now this and this can be cancelled. So it reduces to integral 0 to infinity e to the power minus y dy, which is equal to minus e to the power minus y from 0 to infinity. And if you minus sign, you can take out. Then it will be e to the power minus infinity minus e to the power minus 0. But we know that e to the power minus infinity is same thing as 1 by e to the power infinity, which is 1 upon infinity, that is 0. So it will be minus of 0 minus e to the power 0 will be 1. So e to the power minus 0 also will be 1. So it will be minus into minus, it will be 1. So this will be the value of the double integral 0 to infinity x to infinity e to the power minus y upon y dy by changing the order of integration. So now next, let us come to the next problem. Again, this one, evaluate integral 0 to 2, integral 0 to 2 minus x square y dx dy by changing the order of integration. So now here, let us find out from the given question. What we notice is that since the limit of integration is from 0 to 2 and 0 to 2 minus x, it means that limit of integration for y, it is from 0 to y is equal to 2 minus x, and for x, it is from 0 to 2. So now to evaluate this one by changing the order of integration, I need to find out the new limits of integration. For x, it will be in terms of y, and for y, it will be in terms of constant. So to obtain that new limits of integration, we have to draw the graph of this one. X is equal to 0, x is equal to 2, y is equal to 0 to 2 minus x in order to obtain the new limits of integration. So solution here. According to the question, the limits of integration for x is from x is equal to 0 to x is equal to 2. And for y, it is from y is equal to 0 to y is equal to 2 minus x. Now, next step, what you need to do? Now draw the graph of x is equal to 0, x is equal to 2, y is equal to 0, and y is equal to 2 minus x. Now, out of these four graphs that you need to draw, let us construct a table of this one and see what will be the, so that we can plot those points and get the required graph. This is x, this is y. So when x is equal to 0, then y is equal to 2. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 0. So let us draw now the graph of these four curves. Then what is x is equal to 0? X is equal to 0. That means it is along the the y-axis. So this is x is equal to 0. This is the y-axis. This is the x-axis. This is the origin. Now next, x is equal to 2. So if you mark this point here as 1, then this you can mark it as 2, 3. Then here also it can be 1, 2, and so on. So now what is x is equal to 2? X is equal to 2 represent a straight line. Represent a straight line which passes through x is equal to 2 and parallel to the y-axis. So you can draw the graph of this one. So this is x is equal to 2. Now y is equal to 0 means what? It is along the y-axis. So this is y is equal to 0. Now next let us draw the graph of this one. Y is equal to 2 minus x and see what will be the value of this one. So here see, when x is equal to 0, y is equal to 2. So when x is equal to 0, y will be equal to 2. I'll just mark this point here. And then when x is equal to 1, y is 1. And then when x is equal to 2, y becomes 0. So it will be a straight line which passes through this point. So here it okay, so this will be y is equal to 2 minus x, or you can write x is equal to 2 minus y. So this will be the region bounded by x is equal to 0, then x is equal to 2, y is equal to 0, and y is equal to 2 minus x. So from this shaded region, we need to get the new limits of integration in order to obtain the given double integral by changing the order of integration. So from, you can write from the graph, the shaded region is the required region bounded by x is equal to 0, x is equal to 2, y is equal to 0, y is equal to 2 minus x. Now, by changing the order of integration, therefore, double integral x is equal to 0 to 2, y is equal to 0 to 2 minus x, then x square, y dx dy, this will be equal to what? So what will be the new limits of integration for y now? We need to get it in terms of constants. You can see from here that y is equal to 0. And here you see that it is, this is y is equal to 2. So for that one, you can just draw a line which is parallel to the x-axis and passing through y is equal to 2. So this is y is equal to 2. So the limits of integration for y now will be from y is equal to 0 to y is equal to 2. 0 to 2. And the limit of integration for x, it will be from left to right. On the left side, it is bounded by this y-axis, which is represented by x is equal to 0. And to the right, it is bounded by this line y is equal to 2 minus x. But when you express x in terms of y, you'll get it as 2 minus y. So the limits of integration for x will be from 0 to 2 minus y, then x square y dx dy. So here we need to find out what will be the limits of integration, or what will be the value of this one. So you need to integrate first with respect to x. It will be 0 to 2, then y dy you can take out, then integral 0 to 2 minus y, then x squared dx. So this is called integral 0 to 2, then y dy will be there, and then x cubed by 3 from 0 to 2 minus y. So simplify this one, it will be from 0 to 2, then y dy, substitute the limit of integration for x, it will be from 2 minus y to power 3, then 1 by 3 can be taken outside, then minus 0 the limit of integration. So it will be 1 by 3, then integral 0 to 2, y you keep it as, for the time being as it is, then expand this one, it will be 2 cubed, then it will be 8, then minus 6y, then plus 6y squared, then minus y cubed dy. Now multiply that y inside, then it will become 1 by 3, then integral 0 to 2, then it will be 8y minus 6y squared plus 6y cubed minus y to the power 4 dy. So which is a simple integral, it will be 1 by 3, then it will be 8y squared by 2 minus 6y cubed by 3 plus 6y to the power 4 by 4, then minus y to the power 5 by 5 from 0 to 2. So this is equal to 1 by 3. So it will be 4 into, now here you'll get it as 2 square, replace y by 2, then it will be 3, 2, so it will become 2 into 2 cube plus 6 into 2 to the power 4 by 4 minus 2 to the power 5 by 5. And the lower limit will be 0 only. So simplify this one and let us see what will be the final value of this. It is 1 by 3. Then it will be 4 into 4 will be 16 minus, again this one will be 16. Then plus, so 2 into 2 will be cancelled. So it will be 6 into 4, it will be 24 minus 2 to the power 5, it will be 32 by 5. So this and this can be cancelled. It comes out to be 1 by 3, then 24. You can take the LCM. 20, then 5 2 will be 10, it will be 120 minus 32. So this will be okay, this will be 3, let us divided by 5, so it will be 15 here. So this is equal to, it will be 8. So it will be, okay, 10 minus 2, it will be 8, and 11 minus 3, so it will be 88. Okay, so 88 by 5. So this will be the answer. So hope it is clear now how to change the order of integration.